This is Max Headroom, and what you're about to witness is one of the most sinister-sounding intros to a trailer to one of the greatest epics ever produced in the history of television. And there's more, because you are going to see it as well.
Yes, it.
Yes, it. Yes, namely...
The Algebra Test Review. It is here. We're going to do that now. I'm going to take the practice test. I'm going to work through all of the problems, explain how I'm solving them, and you can use that as a review for the test if you like. If there's problems that you already understand, just skip forward in the video. You don't have to watch the whole thing. But I'm going to work every problem in the practice test. So let's get started. Okay, so the following data set shows the pulse rate of some cattle at a farm. Don't know why you have to take the pulse of cows, but apparently they do. 65, 68, 69, 67, 69, and so forth. Which dot plot best represents the data? All right, well, let's look at our four choices. And if we look at our four choices, there's a difference from the 65s. This says 3, this says 2, this says 3, this says 4. Let's see how many 65s there actually are. So I'm going to go through and highlight them. There's a 65. There's a 65. There's a 65. Okay, it appears there are 3 65s, which means this can't be a correct answer. That cannot be a correct answer. Okay, so these are the only two remaining. They both have the same number of 67, so there's no need to check those. This one has 4 68s. This one has 5. And they both have the same number of 69. So the only difference is the 68. So let's see. There's a 68, 68, 68, 68. Did I miss any? No, it appears not. Looks like there are 4 68s. So it has to be this one.
But you stopped at 102 and then do that graph?
Right. So this is the dot plot that represents it. Remember, just for each number on the dot plot, however many numbers are represented in the data, we put a dot. So there's 365s, there's 467s, there's 468s, 569. All right, the dot plot below shows the hourly rate of some babysitting rates. Nobody charges $3 an hour or less, but there's 4, 5, 6, and 7. There's data for each of those. So based on the data, how many babysitters surveyed earn $5 or $6 an hour? There's a key word, so it's not one or the other. It's or, so it could be either one. Which means we're not just taking this 3 or this 3. We're taking both, because it could be 5 or it could be 6. So it's not just either one. It's both of them. And obviously there are 6, because there's 3 that charge 5 and 3 that charge 6.
So what you do is you get a piece of paper.
Very easy one. Let's look at the next. Okay, this printed on 2 pages, so I cut out the second page and I moved it over so I could see it all on one page.
Then once you've got it done,
the following table shows the number of hours that some students in the class listen to music each day. All right, student just assigned the letter to them, and here's the number of hours they listen to music each day. So we got anywhere from, looks like the lowest is 1/2 and the highest is 6 1/2. I want to know which histogram best represents the data. Now remember, a histogram is a little different than a bar graph or a dot plot in the fact that it just does a range. Like this goes from 0 to 2. So from 0 to 2, and this one goes from 0 to 3. So let's see, 0 to 3, 0. So some go from 0 to 3, some go from 0 to 2. And then, so this one goes by 2s, 2, 4, 6, 3, 6, 9. So we'll see how best to represent the data. Well, the one thing I noticed is we have this 6 1/2.
And you attach a file.
So any of these histograms that only go to 6 would not be able to include that 6 1/2. So it should not be a histogram there because it doesn't have any data for a 6 1/2. So I'm going to rule out 2 answers right away, which is a nice thing. A lot of times you can do that on this multiple choice, is to rule out an answer.
I just wanted to make a point that you weren't supposed to use that.
So it's going to be this one or this one. Well, let's see what it says. It says from 0 to 3, there are 10. This says 0 to 3, there's 11. Between 10 and 12, number 11. Both of them say there's 1 in the 6 to 9. The 3 to 6, this one has, bring it straight over here. So there's 3.
To your Chromebook.
And this one has 2.
to install it.
So let's check the 3 to 6 range. We can check the 0 to 3 or the 3 to 6, but this is smaller. We can see, is there 2 or is there 3? That's between 3 and 6. Between 3 and 6. So let's see. This is between 3 and 6. 4.5 is between 3 and 6. 5 is between 3 and 6. And there's no other ones that are between there. So there are 1, 2, 3 between 3 and 6. It has to be this one here, circled out down here near the bottom page. Or printed it on. So it's not this one because it only had 2 of them in that range. So even if it was a 6, it would still be in this range, 3 to 6. The next bar would be for anything larger than the 6. This would be anything larger than the 3. So if it was actually 3, it would fall in the first one. But we didn't have any of those. All right, moving on. Saul recorded the number of different types of pets that his friends have in the table below. So 3 of his friends have cats, 2 have dogs, 1 rabbit, and 2 have guinea pigs. Which of the following plots represents the data in the table? All right, so it's kind of like a dot plot, but they used X's instead. You know, did cat, dog, rabbit, guinea pig. Let's see the differences. 3, 1, 2, 3. Okay, let's look at cats because there's a difference on there. This is 3. So since this one says only 1 friend has a cat, it can't be that. This one says 2 friends have a cat. It can't be that. Make sure you can see a little bit. It has to be the first one or the last choice. So, dog, they both say 2, so there's no difference there. Rabbit, this says 3 friends have rabbits. This says 1. How many friends have rabbits? Only 1. There's not 3 friends with rabbits. It must be the last choice. Again, you can just roll that. One for guinea pig would be 2. So all of these numbers match this plot right here. And on we go. Okay. The following data shows the wind speed in a city in miles per hour on consecutive days of the month. So 9.4, 9.2, 9.7, 9.8, they're all 9 point something. So it's fairly consistent wind in the city. In these consecutive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days. So which dot plot best represents the data? A box plot. So box plot means it's showing the minimum, first quartile, the second quartile, or the median, third quartile, and the maximum. So let's put our numbers in order because that's what you have to do to have a box plot. So we've got 9.1 is the smallest. We've got 9.2. We have another 9.2. We do. There's another 9.2. Okay, 1 9.3. So Jillian, you are 4 assignments behind. 1, 2, 3 9.4s. And you've got 3 more for this week, so you're really getting behind us, sweetheart. You need to really catch up. So those 9.4, 9.4, 9.4. And we got left. We got 9.6, 9.7, 9.8, 9.7. So 9.6 is our next one. Painful. Now there's 2 9.7s. And then the 9. All right, so there's 11 right there. So our low is 9.1. We could immediately eliminate this one because it said the minimum was 9.2, which is not correct with our data. So this one's out. These all have a 9.1. The maximum 9.8. Those are all the same. So now let's look the median, the one in the middle. There's a difference there. 1, 2, 3, 4, 5, 6. This would be the middle one. 9.4 would be our middle number. Median. 9.4, 9.4, 9.5. It cannot be the one that's 9.5. So there's a difference in the quartiles at this point, right? The quartiles. So okay, well, these an assignment. Have a 9.2 as the middle of the lower section. And a 9.7 as the middle of the, so this will be quartile 1. Because from the median, the middle of the first quarter of data and the middle of the second quarter of data would be the lower and upper quartiles. So we can see of those 5 pieces of information, the third one, the one in the middle, is 9.2. That would be this, not this one. So this has to be our box plot that represents the data we have, just based on where the minimum, first quartile, median, third quartile, and the maximum fall. And we just able to write that down and figure that out. Okay, 2 groups of students were asked how far they lived from their school. So group A says how far they live, and group B. So which statement best compares the mean distances? Mean distances. This isn't the kids that have a bad attitude and bad
talks about
behavior. This is the mean. The mean is the same as the average. All right, we think of that as the average. So when we talk about the mean, we talk about what is the average number. So let's figure out what the mean is for our first group. So what we're going to do is we're going to add them all up. 1 plus 1.5 plus 3 plus 3.2 plus 2.8
and make sure
plus
it's a title and make sure it's
1.5
so those are
plus
the different things
1.8
that
plus
science graphs
2.5
are.
plus
Have, then maybe
2.2.
you
So
might
all
do
of those
in
add up to
math
19.5. And
So
how many
in
did
the
we
third
add up?
page of the
1,
lesson,
2,
they
3,
want you to
4,
graph
5,
this
6,
data.
7, 8, 9. There were 9 pieces of data, and they added to 19.5. So divide by 9,
that you have at home.
and their mean, their average is 2.166 repeating. Okay. Now let's check the mean of the second one. 2 plus 2.5 plus 3.2 plus 3 plus 1.8 plus 2.4. You want to pause this and calculate it and see if you come up with the same answer before I show it. Go right ahead. You can always do that. 21.2. We're going to divide that again by 9. There's still 9 pieces of information.
4 assignments behind.
So the mean here is
plus the
2.35
So
repeating.
if you did nothing until
So it says,
next Monday,
comparing them, are they equal? Is greater for group B? Is group A double what group B is, or group B double what group A is? Well, 2.16 and 2.35, neither one of them is double the other one. That means one of them would have to be 4 point something, right? If it was double.
Okay.
But group B is a larger number, so it is greater for group
All
B
right. I said
than group
you're
A.
right.
So that is the correct answer.
Okay.
Right there, greater for group
I apologize.
B. Just had to calculate the means for the 2
We'll talk
groups.
about 102 and
All right, let's look at number 7.
So
The employees of 2 companies were asked how many times they checked their email during weekends.
Says that you did 1.02.
So everybody said that they checked their email on their days off on the weekend. Based on the table, which of the following is true?
No.
The interquartile range for company A is 2 more than the interquartile range for company B, et cetera, et cetera, et cetera. So we have to do the interquartile ranges. Interquartile ranges for these 2 pieces of information. So let's calculate that. We got to put them in order to do ranges, right? To do box plot information. So 2 is the lowest. There's a 2. There's a 2.
Not done it. Not
there's
submitted.
1, 3.
So a better place to look.
We got a 4 and a 4.
Is the grade screen.
4 and 4. We've got a 6.
The grade screen will show you
and
what
I have
has
a
been
3/8. 3/8. Okay.
So if you go to the menu and look at the grade.
For the second one, we have again 2, 2.
So don't depend on those
There's another 2.
Don't do it.
Now we have a 3. We have another 3. We have a 4.
So let's start over. You need to do 1.2.
5 and 2
Having
6.
3 check marks, thought it was done. It's not. Okay, so then what about
5 and 2
1.05?
6s. Okay, so we're comparing the interquartile range. That is where we find.
There's nothing.
If I just drew a box plot here, put our median and we had separate. Whatever quartile 3 is, if we subtract quartile 1, that gives us all of this right in here, which is our interquartile range. It's where we expect most of the middle part from the first quarter to the third quarter.
1.05 is the caliper.
The bulk of half of our numbers should be right in there.
And that's the one
The
I was talking
interquartile
about in the class where you use the
So,
pictures.
our median will be in the middle.
You don't
Right,
have
so
to have
that's
the equipment.
4 for our top piece of information, and that's 3 for our bottom piece of information. So that leaves 4 numbers here and 4 numbers here. So what's in the middle?
Two assignments.
Well, for this one,
behind.
the lower quartile would be at
So
2.5.
basically, one
Between 2 and 3 is 2.5. Between this one,
from
it's
each of
2,
these that would be
because both of them are 2. So the middle number is
plus
going
the
to
3
be 2.
assignments this week.
What's
So
between
technically
here?
you have
Well,
5
that's an
assignments
8
to do.
because they're both
by
8s.
Sunday.
And this is a 5.5. Right, between the 5 and the 6 would be 5.5, exactly. So what's the interquartile range? We take this third quartile, which would be 8, and we subtract the 2.5. 8 minus 2.5,
Next time you have to come
5.5. Right, this is our IQR.
I will keep you in class.
5.5 minus 2 is 3.5. So this has the interquartile range for company A of 5.5 and for company B 3.5. So the interquartile range for A is 2 more. Yes,
Okay.
that's 2 more. A half more,
Then,
1 more, 2.5 more. This is exactly 2 more for company A than for company B.
no, it's okay.
So that would be our answer for number 7. Let's move on. Okay, the data set below shows the number of books checked out from the library during the first 2 weeks of the month. 99, 29, 30, 42, 35, 36. These are all the 30s and 40s and upper 20s. Except for this 99.
All right,
it's 99. So which of the following statements is true based on the data set? There's 1 outlier indicating very few books were rented on that day. There's 3 outliers indicating very few books. There's 3 outliers indicating an abnormally large number of books. There's 1 outlier indicating an abnormally large number of books. Well, look at this. There's 1 outlier. 99 is nowhere near the rest of the data. Most of the data is grouped in pretty well, all between the upper 20s and lower 40s. It's all in there, except for this 1 where it shows a 99. Now, what are these numbers representing? This is the number of books checked out. So there's 1 outlier, and it indicates there was an abnormally large number of books. Not that there was few books, because 99 is a lot bigger. There's an abnormally large number of books. So this is our answer right there. All right, let's move on. Okay, a box plot was made to represent the number of matches won by 14 participants in a tennis tournament. Okay, so the box plot had the box shifted to the left so that the right tail is much longer than the left tail. So if we just kind of get a visual of that. All right, so the box was shifted this way, but there's an abnormally long tail to the right, much longer than the left. So based on the box plot, which conclusion is correct? The mean and median of the matches won are equal. Well, the box plot can't really tell us what the mean is. That's the average numbers. That's where we add them all up and divide. We don't know any individual numbers on this, except we would know what the minimum and the maximum is, because whatever those values are on our box plot, we would know those. But we wouldn't know any of these in between, except for the median, perhaps. And the median maybe or maybe not, because if there's an even number, if there's 8 pieces of information, it would be what between 4 and 5. So the 4 was a 5, and the 5th piece of information was a 6. It'd be 5.5. So even we wouldn't know the median. So we can't tell the mean of that. All right. So the mean of the matches won is less than the median of matches. So we don't really know that for sure either, because we cannot tell mean from box plots. We can't tell the mean. Most of the participants won many matches, but some participants won very few matches compared to the others. So does this say most of them won many? Because this is the number 1, right? This is showing that half the data, right, the third quartile, fourth quartile, half the data is on that end. So that means most of the participants won fewer matches, right? Fewer. This is the smaller numbers. But some participants, right, we had some outliers won many matches that made it bigger. But most of the data was right here, at least half of the data, right? Half of the data. And 3/4 of the data, right? Because this is the third quartile, first, second, third. 75% of our data is smaller than that. So most of the participants won 2 matches, but some won very many compared to the others, which made that tail really long out there. So if it helps to make a visual of this one, does it? Go ahead and draw one. All right, so the following data shows the prices of different types of hot dogs at a store. So they cost $6, $8, $7, $6, $5, $7, $5, $28, and $30. Now, I'd like to see what kind of hot dogs those are, because that is quite a difference. Which statement's correct about the box plot? So if we made a box plot for that, so the box plot will have its right tail longer than the left because of a few exceptionally high prices make the distribution skewed to the right. The box plot will have its right tail longer than the left because a few exceptionally high prices make the distribution skewed to the left. The box plot will have its left tail longer because of a few exceptionally high prices. The left tail longer, exceptionally prices skewed to the right and left. So what would that do? We would have, most of the information would be down here because we got all of these $6 to $8 ones, but then we got these $28 and $30 ones that push this way out here because there's just two pieces. Most of the data is way down here between $5 and $8, right? $5 and $8 would all be down here. You have this long tail to go out here and pick up this $30 maximum, and there'd be a $28 one that's in that range, right? There's another piece of information in there. So the left tail is definitely not longer because that's where most of the data is. There's just a couple that you have to draw way out there to include those two out there. So is this skewed to the right or skewed to the left? Well, if we think about how our data is, if it was all symmetric, it would be somewhat like this, right? We'd have most of our information be between those two, right? If we was drawing like a diagram like this, like a graph, if it was perfectly symmetrical, it would look like that. But this one is got most of our information right here, and then we go to, oh, we got these ones way out here that we have to go include, way out there. So this shows that it's skewed to the right. The right side is pulled way out there to include those information. So this is skewed to the right. The right tail's longer. Pulls that way out there. All right. Let's move. Henry collected data on the favorite type of food of the students of two grades. So this table shows the relative frequencies. All right. So this doesn't say there's half a student in grade 8 that favorite food is a burger. No, this is saying that 0.5. See, notice the total is 1. This is not the actual data. This is the relative frequencies. So basically, this is percentages, where 1 equals 100%. 1.0 is the same as 100%, right? Because as a decimal, 100% is 1. If you convert it to decimals, this is in decimals. It's the same as 100%. So this counts everybody. So this table gives us that. So these are the total columns, right? These are the total columns. So the actual information, the students is right here. So which statement's most likely correct? In grade 9, 53 students like burgers. Again, this is 0.53. That doesn't say there was 53 students. That means 0.53 of the total students, if we multiply that. Like burgers. So it's not just the number of students. And this one said 10 students like sandwiches. Again, the 10 is not the actual number. This is a percentage. So it's either 73% or 40%. Right? So in grade 9, 73% of students like noodles. Where's grade 9? There it is.
Okay, so
all right. So the 73% like noodles. Noodles is right here.
Put yours on there.
And this is their favorite food. So this is what they like. 0.27. So that would be 27% is their favorite food is noodles. Which means 73% their favorite food is something different. Not that one. 8th grade, 40% of students like noodles. 8th grade,
yep, no problem.
0.40 like noodles. That is 40%. This is our correct answer. 0.4 is 40%. So since this is a relative frequency, we know that is 40%. All right. Andy found that 57 students in their school knew French, and 23 of those students, that's important phrasing, of those students knew Spanish as well. Okay? There were 11 students who did not know French, but they did know Spanish. And there were 4 students who knew neither one, neither French nor Spanish. So which table best summarizes the data collected? All right, so the first thing is we can look at knew French or did not know French, right? So we can ignore this top column for the moment. We're saying, okay, how many knew French and didn't know French? So knew French, and the totals out here at the end, this is the total students that knew French was 91. The total that did not was 15. There's 106 students in the class. This is total students in her school. Students in her school, she surveyed 106. So this is saying 91 knew it, 51. She said 57 students knew French. Well, that's not 57, so it can't be this one. That's not 57. It can't be this one. This is 57, this 57. So it's one of these two down here. So those two are both out. Okay? 57 knew French, and 23 of those students knew Spanish as well. So here's the new Spanish. So the new French, it says also 23 going up and down. This many know Spanish, this many do not know Spanish. All right? So both of these show there's 72 total. This one was wrong. So going no Spanish, 34 of the 72 know Spanish, 38 don't. 27 know Spanish, 45 don't. I know which one's correct. So she said 23 of the ones that know French know Spanish. No French, also know Spanish, 23. No French, also know Spanish, 23. Those are the same. Okay? There were 11 students who did not know French, so they would be in the bottom row, but knew Spanish. 11 students. This says 11 students knew Spanish, but they didn't know French. This one says there's only 4. This is our correct answer. We found the difference. And it says there were 4 who didn't know either one. Well, didn't know either one would be this category, and didn't know either one this category. Where do they cross? This is the ones that don't know either. So it has to be 4. Or in this one, we see that was 11, so that was wrong. So we just follow the information, look at what number they're reporting for the information, see which ones match. All right. Out of 180 students at a summer camp, 72 signed up for canoeing. And there were 23 students who signed up for trekking, and 13 also signed up for canoeing. So we're going to use a two-way table so we can answer the question, approximately what percentage of students signed up for neither one. So there's 180 students. So we're going to make our table here, and we're going to do our rows, columns, and we're going to say, we can do it either one. We'll say canoed. There's signed up for canoe or no canoe, right? It says some signed up for canoeing, so others did not. And then trekking is the ones that trek, and this one's did not sign up for trekking, right? And then these are totals. We always have totals there at the end. Okay, so I want to make these lines a little darker to show our, this is our data, these are our totals out here. Okay, out of 180 students, we know there should be 180 right here. 180 students total. 72 signed up for canoeing out of the 180. So for canoeing, the total, there's a total of 72 signed up for canoeing. Now we know there was 180 altogether, so that must have mean there was 108 that did not sign up for canoeing. We can just do the math to fill in the gaps that it doesn't tell us. There were 23 students who signed up for trekking. Trekking, going up and down. There was 23 students that signed up for trekking. That was total. Our total number of trekking students, which means there was 157 who did not sign up for trekking. Okay, and of those 23 students, 13 of those students also, that's the key word, also signed up for canoeing. So this is signed up for trekking, this is signed up for canoeing on the top. So that means there was 13 of them that go right here. That their yes trek and yes canoe is that box right there. Right? Because that's the ones that signed up for both. So we're trying to figure out which one signed up for neither, which would be no trekking right? No canoeing, no trekking. That'll be this box, right? We're trying to figure out this box right here. So let's just do the math. If there was 13 that signed up for trekking that were signed up for canoe, and there's 72 total signed up for canoe, how many does this have to be to total 72? Well, 13 plus 59 would equal 72. So that's how those two fill in to total that. Up and down, if there was 13 trekkers that signed up for canoeing also, how many did not sign up for canoeing? If there were 23 total, it must be 10, right? Because 13 plus 10 is 23. This we can figure out this way or this way, either one. Well, it's probably easier to go this way. There's 108 total that did not sign up for canoeing. 10 of them did sign up for trekking. What number here has to go with the 10? Of course, total 108. Well, that's going to be 98. 98. So this is the number we're looking for. And they want to know percentage. Okay, that's the key word, percentage. What percentage of students signed up for neither one? Well, it's not 98% because this is the total number of students, not the percentage. 98 did not sign up, but out of how many students are there? There are 180. So 98 of the 180. And this is the no trekking, no canoeing group. What is 98 divided by 180? 98 divided by 180 is about 54%, right? 54.4. That would be this choice right here. 54% of our choices. About 54% of them did not sign up for either one. There you go. Hey, when you do these tests and stuff, have some pencil and paper. This is hard to do in your head. Hard to keep all that straight in your head. Okay, this table's below, and there's choices on another page that I cut out and moved to this page. Table below shows the air pressure in pounds per square inch at different altitudes in thousands of feet. All right, so this is altitude up here, 5,000, 10,000, 15,000 to be 1,000 feet, and the air pressure. Now, so air pressure getting lower as you climb higher. So which scatter plot best represents the data on the table? All right, so we just have to match up. It means the altitude is down here. So when the altitude is 5, the air pressure should be 12.4. So let's look. Use a ruler or whatever. It's 5. So it'll be about right there. Is that 12.4? No, that's 25. Right? That's not even close. Can't be that one. How about this one? 5 is going to be about in the middle there. So that's going to be that point right there. And that could be about 12.4. Could be that one. This one's just like that. 5, but could be this one. Those are both okay. 5, okay. So the 5 is about the same on both of those. So let's check the next one. 10 is 10.2. 10, yeah, that's about right. That's about right. Well, this one moves over to the right. That's the 15. This dot's at the 15. All right. So this is 15 is 10.2. We're off on this one. 15 should be down to 7. See, 15 is still way up here. On this, it should be down here. So that's why this one can't be it either. So 15 should be 7. So 15 will be in the middle here. So that's this dot. And that is at 9. Here, the 15 is this dot. And that's at 7. Okay, so this one is wrong. We just have to keep checking each one until we eliminate everything that's wrong, which we did. By the third piece of information, these graphs could not be it. And we can continue to check those, but since we've already eliminated all these others, we won't continue down that. But you certainly can. All right, here's a scatter plot that shows the number of DVDs that Aaron sold in different months. So Aaron's a DVD seller, and he sold 20 in month 1, 50, because it's right in the middle of the 40-60 month 2, 3, 4. Every month sells a lot more. What is the approximate predicted number of DVDs airing this on the 13th month? Well, we've only got up to 5. So month, and then sold. We'll just kind of see what the pattern is. 1, 2, 3, 4. We got 5 months here. The first month he sold 20. Second month he sold 50. Third month he sold 80. And that is 110. And that is 140. So what's going on each time? Each one of those are plus 30. Every month he's selling 30 more. So if we went to month 13, that's 8 more months at 30 each. Right? So 8 more months at 30 each. 8 times 30 is 240. So he would sell 240 more by month 13. He had 140 at month 5. So add those together. 140 plus 8 more months. Plus 8 more months. 380. We got 380 by the 13th month. We keep going up another 240 from that point right there. Number 16. All right, an equation was created for the line of best fit from actual enrollment data. It was used to predict the dance studio enrollment value shown in the table below. So here's what they did. There's the actual numbers. They had predicted this based on their graph. They did a line of best fit and said, this is what it shows it should be each month. And here's the residuals. And the residual is the difference between what you predicted and what actually happened. Right? So if we had a graph and we had a line of best fit that went like that, and we had data that this was perfect, this was off, this was off, this was off a bit, this was off, this is off, this is off. Our residual would be, what is the difference between there? We would calculate that residual and say, oh, that was plus 5. And this one was minus 6. And this was plus 11. You know, that's the residuals, is figuring how far was those off. These are residuals. It's how far are we away from that line of best fit. And so we have all of these residuals. So analyze the data, determine whether the equation that produced the predicted values, this line of best fit, did it represent a good line of best fit? How accurate was it? Well, the fact that it was off 100 or something doesn't matter because it was, negative 100, positive 90. What matters is overall, if we add all these together and get to the end, are we at 0 or are we close to 0, right? Some of them are above and some of them are below. Remember, a line of best fit should be about in the middle, where about half of the information is above the line and about half is below the line, and we should have a residual that's very close to 0 if it's a good line of best fit. So let's see what our residuals add up to, and let's see how close this was. All right, clear. 90 minus 50 minus 100 minus 100 plus 150. It's a positive. Minus 50. Turns out it's a minus 60. Minus 60. So the equation is not a good fit because the sum of the residuals is a large number. It's not a good fit because the residuals are all far from 0. It doesn't matter if they're all far from 0. It's their total. It's their total that matters. So it is a good fit because they're not far from 0. Or it is a good fit because the sum is a small number. Negative 60, that's a big number compared to 0. It's 60 away from 0. It's 60 away from 0. No, it is not a good fit because the sum is not close to 0. It's a large number. It's not a small number. Negative 0.5 would be fine. So, something really close. Negative 60 means you're a long ways away. Should be very close to 0. Close as you can get. The closer the better. The closer the better your line of best fit is. A picture is enlarged by keeping its width the same and increasing its length. Okay, so it's going to be the same width, but we'll increase the length of this picture. It'll make it look weird. The scatter plot shows the perimeter of the picture for different lengths. Okay, the perimeter for the length. If we take it from the length from 20 to 30, the perimeter goes up from 60 to 80. You go up to 40, now it goes up to 110. Go up to 50, now it goes up to 120. Which function best represents the data in the scatter plot? Okay, we need to figure out if this line continued. I'm just going to take my railroad show. Going to see that's how the trend is going. If we connected those. And one thing that's important, if we're looking at which function best represents it, we need to make sure we have, first of all, our y-intercept is going to be accurate, right? That's the y-intercept. Y equals mx plus b. We have slope in front of the x, and we have the y-intercept. That's the b. So what's our y-intercept? We have a choice of either negative 20 or positive 20. Well, obviously, even before I drew the line, we could see that it's going to cross above the 0. It's going to be a positive y-intercept, right? So it can't be the negative 20. That's not the y-intercept of that line. It is not the y-intercept of the line. It's got to be the plus 20. So now it's either is the slope 1, does the slope equal 1, or does the slope equal 2? Which one is it, 1 or 2? Well, let's see. As this increased 10, this is the x's. Remember, the y, the difference in the y's goes on top. The difference in the x goes on bottom. How much did the x change? The x changed from 20 to 30. That's an increase of 10. And what did the y change? It went from 60 to 80, it looks like. 60 to 80, it went up 20. 20 over 10, it'd be 2. Must be that one. 2x plus 20. So it's not a slope of 1 because it would be going up. We would have to go up 30 to go up 30 here. So from 20 at 60, we wouldn't get to 90 until we got 30 more down here to be a slope of 1. So that's a slope of 2. Number 18, the function below models the correlation between the number of hours a plant is kept in sunlight and the height in millimeters in which it grows. So 2 plus 4x. So it's still a y equals mx plus b, but they're putting it b plus mx. Right? They just put the y-intercept first. What does the y-intercept represent? All right, the height is y, so this is total height. The hours is the x, so the hours is right there, so 4 times the hours, and then 2. Well, the y-intercept, if we're graphing that, and it started at 2, and it goes up like that, and this is height, and this is hours in the sun, what is it showing? It's showing the more hours it spends in the sun, the higher it goes up, right? The taller it is. So what is this right here? It's 0 hours in the sun. That's the original height. This means started at this height before we start putting in the sun. This is where we started measuring the height. And it was a 2. And that's what the plant started at, 2. And then for every hour, it grew 4 millimeters for every hour we put it in the sun. See, the height of the plant increases 4 millimeters for every hour, but that is not the y-intercept. That's what the slope represents. The y-intercept. Okay, the graph shows the girth of a trunk. The girth is how big around it is. The girth of a trunk of a fir tree after a different number of years. So this in centimeters. So it started at 5 centimeters, little bitty, right? Little bitty tree. And then over the years, it grew up to be 40 centimeters. It's getting much bigger tree over a number of years. So what does the y-intercept represent here? What is this? Years is down here. So at 0 years, it has a 5. Well, that is the original girth. It started when it was planted, it was 5 centimeters. 5, that's the y-intercept. Right? So make sure when asked about y-intercept, you're not saying something to do with the 12. Because look at the graph. What is the y-intercept? Where does it intercept the y? Where does it cross the y-axis? 5. Your answer should have something to do with the 5 first off. Right? Because that is the y-intercept. And then the second thing, make sure you're telling correctly what that 5 represents. Number 20. The graph below plots the values of y for different values of x. Okay? It doesn't say necessarily what these x's and y are. It's just showing when x is 1, y it looks like it's 1. When it's 2, it's 4. When it's 3, it's about 7. All right? Which correlation coefficient best matches the data? All right, correlation means if we drew a line of best fit, how close The closer it is in there, correlation, how things are correlated. We're looking at statistics. The correlation coefficient will tell us how close all the data would be to that line of best fit, right? And the correlation coefficient, the closer it is to a 1, the better it is. The better it means that there's some correlation in there.
So in the picture,
If this was the number of hours studied in your grades, and we said the number of hours studied, it shows that the more hours studied, the higher your grade is. It looks like there's a correlation there. Now, there could be other factors, so we can't say it's a causation, because there could be other factors in there that would also affect that. But it certainly looks like it is a strong correlation if it's close to a 1.
Okay, now listen.
All right, if it's going down, it would be a negative 1. Right, when the graph is going down, a negative 1 would be a strong negative correlation. Okay, strong negative correlation. Either way, correlation coefficients are between 1 and negative 1. They're going to be somewhere in between there.
And that's going to give you the
And the closer they are to 1 or negative 1, the stronger it is. If it's 0, that means there's no correlation. It's like just because you study more doesn't affect your grades, because the data shows everywhere, right? If we had numbers all over the place for that, we say there's really no correlation. So this one looks like it's very, very close to the line of best fit. It's almost exactly a straight line. If it's almost exactly a straight line, that's going to be very, very close to 1. Very, very close, because it's close to a straight line. So it's not to be a negative 0.5. It's certainly not a 0. This is a really good correlation. 0.25. This is the one that is closest to 1. 0.9. So that must be about a 0.9 correlation coefficient, because it's very, very close to a straight line. So the correlation coefficient should be very, very close to a 1. So that's what you're wanting to look at, correlation coefficient. This statistics stuff is where math really gets into practice, and companies spend billions of dollars trying to figure this stuff out, trying to figure out if they can do something to increase sales or something like that, right? They'll figure out the correlation coefficient on that. If we do this and sales go up, is there a strong correlation that doing that is what caused it, right? How strong is the correlation that more advertising creates more sales, or advertising the Super Bowl does that, because that's a lot of money? Is there a strong correlation in the increase in sales, or does it not really help as much as just regular ads during other shows? All kinds of stuff where companies use this, so it's good. If you get good at that, you can make a lot of money working for companies that are dying to figure that stuff out. All right, the table below shows the values of y for different values of x. So here's the x, here's the y. It says the correlation coefficient for the data is 0.0715. What is true? So is there a strong positive relationship? Is there almost no relationship? Is there a strong negative relationship or weak negative? Well, first of all, this is not a negative number. This is a positive number. So it can't be a negative relationship in any way. So the question is this a strong relationship or almost no relationship? So is this closer to 0 or is it closer to 1? 0.07 is really close to 0, because 0.1 would be bigger, 0.2, 0.3, 0.4, 0.5. 0.5 would be halfway in between. This is smaller than 0.1. It's 0.07. So there is almost no relationship between the x and the y. Which means if you tell you what the x is, you wouldn't be able to predict the y, because there's really no relationship. There's not a strong correlation between what the x is and what the y is. Right? If there's a strong correlation, if I tell you the x, you can tell me what the y is. And say, what if the x is 8? Well, you could use this and tell me it's probably going to be around 20, 21. And if we got that information, you'd probably be correct, because there's a strong correlation here between what the x is and what the y is. And you can tell that. This, no way. Not a strong correlation. All right. Let's do number 22, which is the last one. Sarah described the following situation. When one patient with a common cold takes a medicine and the other patient does not take any medicine, the person who takes medicine recovers faster than the person who does not take medicine. So which of the following best describes this? Is this an example of both correlation and causation? This is an example of neither correlation nor causation. This is an example of correlation, or this is an example of causation. For it to be causation means that we could test this under controlled environments and prove it's true, right? The controlled environment where we control all the other factors, to where the only factor would be just what we're testing. And so in this case, that's something we could do. We can control, this person never takes any medicine, this does take it, and we can control and see, does that affect how fast they recover? So there is certainly some causation in that, because when they take the medicine, they recover faster. Is there correlation? Correlation, we got to have some data. We got to have to look and see how strong correlation is. That consistent? Do we have measurable data to say if they take this much medicine, they get, well, this much faster? We don't have any correlation data. We do have causation. So this is an example of causation. If we had data there that said, if they took one dose, they got, well, 1 day faster. If they took 5 doses, they got 5 days faster. And we start looking like that, we could kind of prove a correlation in there over the amount of medicine taken and stuff like that. So this is just saying you take medicine, you get well faster. And we can look at that in the control environment. So yeah, there's a direct cause there. That's a direct cause. It's not just coincidence. If it's just coincidence, it's not causation. So causation means it caused that to happen. So causation. All right. We are done with that. If you struggle with any of that, go back and look at it again. You can always pause and review things. And you can make sure you understand what I put on there. If you have questions on any of that, let me know. I'd like you to watch this, or at least the parts that you struggle with. You don't have to watch the whole video before you take the test, just to help you out and be able to do your best. But anyway, got problems, email me, let me know, come to class, whatever we need to do, and we will see you next time.